Okay, this video is going to look at or focus on looking at some of the slightly more complicated questions when we're talking about tangents and normals and calculus. So these are the 4 questions that we're going to go through, so feel free to pause the video to have a closer look. We'll go through them one by one, starting with this example. Now get your note sheet ready because there's just some basics that I think you need to be aware of, okay, with tangents and normals. So first and foremost, and this is stuff that we've already gone over, right? Notice your notation. So the first derivative is represented by f dash of x or dy by dx. That represents the derivative of y with respect to x. And we know that the derivative is representing the instantaneous rate of change at a particular point. It can also be asked that that's the slope at a point. And of course, that also means that that's the slope of the tangent at a point. So if we've got our good old friend, a nice quadratic here, if I wanted to find the slope at that point, okay, we would differentiate our function and we would pop in the value that we have at our x, and that will give us our slope. And we know that this situation here, this would be a positive slope. If I tried to get the slope up here, this would be steeper, okay, bigger number. Obviously, if I tried to get the slope over here, it would be negative. And at the vertex, that leads us into this next bit here. The horizontal tangent has a slope of 0, right? So right at the vertex there, we get a horizontal tangent, and you can see there, of course, we know that the slope of a horizontal line is 0. So that's why we have this property. So as soon as we see that the slope is, or the tangent is horizontal, straight away we should write down f dashed of 0 equals, f dashed of x equals 0. Right, a couple of other words to look out for. If a question says parallel, well, straight away we're going, well, that means same slope. If a point lies on a line, 3, 6, remember your notation. That's saying when x is 3, y equals 6. And we can write that nicely in mathematics, f of 3 equals 6. Right, you might also come across a question that might say the tangent at x equals 2 is this, and they give you the equation of the tangent. So if we're given the equation of the tangent, we can see this is our slope, right? Remember, y equals mx plus c. We know that the value in front of x there, the coefficient of x, is the slope. So if it says that this is your tangent, then clearly, remember what this is saying is the derivative will equal 5 when x is 2. So just sharpen up some of our skills about how to read mathematics, all right? What else do we know? We know that a normal, okay, back up to our equation, our little graph over here at the top. So if we're talking about a normal at this point here, it's perpendicular to that tangent, okay? So that's what we call a normal. And we better label that the other one is the tangent. Oops. It's not a great diagram, but you'll survive. So if the slope of the tangent we figure out is 3/4, then the slope of the normal, we flip and reverse the sign, so the negative reciprocal. So let's get stuck in to some of these questions now that we have those notes under control. And let's do the first one. So find the equations of any horizontal tangents. All right, so as soon as we see horizontal tangent, we should be writing down dy by dx equals 0. And of course, if we want to make dy by dx equals 0, well then let's actually find dy by dx. So we'll just differentiate that. I'll pause because I think you can do that. Okay, so when in doubt, differentiate. Okay, now let's actually read the question carefully. What is it that they're asking? Find the equations of any tangents. Okay, so what do we need to find the equations of tangents? We need the slope, which we know is going to be 0, but we don't have a point. So that's when it comes back to our derivative. And what we're saying now is we have to solve for what values of x will our derivative actually equal 0. And we see it's a quadratic, so let's pull out any common factor, right? Remember the process, everything on one side. Pull out your common factor, and we can factorize this. So x take 2, x plus 2. course, if this was in a test situation, didn't want to solve, remember you can use your calculator. So we've got x could be plus or minus 2. Right, it's handy to know what it is that you're actually doing here. So I'm going to just graph this function, type the pink one there, so draw. I made our scale to be standard, so I would like to have a little bit more space top and bottom. So shift view window, going to make, let's just go minus 20 and 20. Okay, so we can see where would we have horizontal tangents, right? At the top here, that we call that a maximum, and our minimum, that's where we will have our 2 horizontal tangents. And you can see that that sort of lines up with x equals 2. I'll just cut and paste that. So we can see this one here, this is when x is minus 2. This, oops, imagine that actually touches. That's the horizontal tangent we're after here. And of course, this is our horizontal tangent we're after here, and that's going to be when x is 2. So remember, to find the equation of any horizontal line, it's basically y equals whatever the y value is that this passes through. So it's 2 something. We need to find this y value. So again, read your mathematics. It's this function here. That's the rule that has y. So to find my y value, I'm going to say y equals 2 cubed minus 12 times 2 plus 2, and that will give me my y value. Okay, negative 14, so that's giving me that coordinate there is 2, negative 14, and so therefore the equation of the tangent, right, is y of the horizontal tangent is y equals minus 4. And do the same, substitute in x is minus 2. Just be careful, remember when you're popping it into your calculator, make sure that you use your brackets. Okay, so you should get 18, and so what we're saying here is that, let's go blue, so many colors, so the equation of this line, this horizontal tangent, that's going to be y equals minus 14, and the equation of that horizontal tangent is y equals 18. And you know, check, is it reasonable? Of course, minus 18, it's up there, that's good. Minus 14 down. So hopefully you understand that. So let's get stuck into our 4 questions. Find the equation of the horizontal tangent. So again, as soon as we see horizontal, we are straight away thinking, stating, and you know, write down your info. So dy by dx equals 0. So now let's find the derivative of this function. And before I actually differentiate, I'm just going to rewrite that so my head isn't hurting too much. We know that the square root is a half. Okay, it just makes the differentiation process a lot easier. So dy by dx equals 2x to the minus a half minus 2x. And we are trying to solve for what values of x will this equal 0. So that's 2 over root x. Take 2x. You could use your calculator if you want to solve n to solve this if you wish. I'm just going to say, well, all over 1 fraction 2x root x. Okay, so remember, making it 1 fraction times your denominators together, then cross multiply. And of course, we cannot have x equaling 0 here because you cannot divide by 0. Simple inspection, you can see that the only value for x here is going to be x is 1. Okay, now find the equation of horizontal tangent. So when x is 1, we want our y value. So we're going to pop that back into the original equation up here, the one that says y. So it's 4 times the square root of 1 is 1 minus 1. So y equals 3. Not only is that the point that the tangent lies on, so this graph, I think it looks a little bit like this. So at 1, let's imagine that's the 1. So that's our horizontal tangent here at y equals 3. So it's passing through that point 1, 3, but it's horizontal, and that's the equation of the horizontal tangent. Okay, onward and upward. You have a read of that, see what you're going to do. So, oops, okay, I said oops because actually when I was making this question, you make them by putting the numbers in, then you whack the k in. Anyway, let's imagine we don't know what that is, so don't rewind the video. So find k, given that has a gradient of -4. So as soon as we see gradient, right, we're going, that's dy by dx. So let's differentiate. So you go ahead and differentiate. Pause the video if you so desire. We should be able to do this in the blink of an eye. So minus 12x squared plus 2kx minus 6. Okay, and what this is saying is that when x equals a half, dy by dx is going to equal -4. So let's sub crazy. So minus 12, a half squared is a quarter, plus 2 times k times a half, take 6, and basically simplify and solve. I'll just pause. So minus 12 times 4 is minus a third, 2 times a half is 1, you've still got the k there. Pop everything on the other side, and therefore k is 5, which if you rewound and saw, that is exactly what the k value is. But pretty simple, but it all comes down to reading the information that you've got and knowing where you can use that onward. Let's look at number 3. Okay, so once again, know what you're trying to find. It's asking you to find the equations of tangent, so that means we will need a slope and we'll need a point to the curve. Okay, now parallel. So it's parallel to the tangent at x equals -2. So that's the first thing we're going to need to find is, well, what is the slope? What is the tangent when x equals -2? So once again, let's differentiate. That good old philosophy, when in doubt, differentiate. Okay, so we're going to differentiate and sub in -2. Okay, so I've differentiated, I've substituted in x equals -2, and we've got that at x equals -2, the derivative is equal to 48. So what's actually being asked here? So what's happening is that when x is, let's say, -2, right, the slope of this tangent is going to be 48, so pretty steep. But you can also see that if I draw another line, probably somewhere here, these two will be parallel, and it's also going to be a tangent at another spot on the curve. So it's this other spot that we are trying to find. So in order to do that, we're saying, okay, when else, for what other values of x, is the derivative going to be equal to 48? Okay, as soon as we see we're solving a quadratic, so we fall back into our good old habits, we get everything on one side. 12 take 48 is -36. By all means, you can go and use your graphics calculator, but you should be at the point where you could solve this pretty quickly by hand. You see there's a common factor, don't forget my x there, x squared, take 4x, take 12, so we're looking for two numbers that times together give me 12, but add up to be -4, so that's going to be 2 and 6, so +2, take 6. Now, I know that I'm right here because from this x equals -2, which is the value that I had up here. If I didn't get that as one of my solutions, then that's telling me that I'm wrong, and I need to go back and see that there's an error. So now I've got my second solution, which is x equals 6. So this would be my point, x equals 6. Okay, so I've got the point, I've got the x value of 6, but remember, go back to the question, we want to find the equation of the tangent. So what two things do we need to find the equation of the tangent? We know that the slope is dy by dx, right? We know that's 6, and we don't know it's 6, silly me. It is 48. Okay, it's 48. Slope is 48, and my point is 6. How do I find the actual point? I have to substitute it back, right, into my original here. So when x equals 6, what will be my value? You can do that. You'll get your y value, and away you can go. Find the equation of that tangent because we should know by now how to find the equation of the tangent when we have the slope and a point. I want to take this opportunity to see, can you check this using your calculator? So I just happen to have that already in there, so we'll just select it. We will draw. There we go. Now I'll go sketch, tangent, right? But we want the one when x is minus 2. That was one of our solutions, and you can see here my derivative is 48. That's great. I'm now going to exit, not still there, so draw. Now I'm going to go tangent when x is 6, because that was the one we want to check. Once again, the derivative is 48. If I press enter again, then you can see the equation of the tangent that you should get. If that's not coming up for you, it means you have not got your derivative on from something we talked about in previous video. So you just go shift menu, scroll down, and you turn your derivative on. Okay, so hopefully that makes sense to you. Okay, and last one, consider the curve. Ooh, now we've got some constants in the mix. Find A and B if the tangent at x is 1/3 is this. Now, if this is my tangent, color should we have? Go back to the pink. If this is my tangent, remember when an equation is in the form y equals mx plus c, this m value, the coefficient, is my slope. In other words, that is dy by dx. So I can rearrange this a little bit. We can have 12 take, we will have 12x take 7 equals 3y, and therefore y, divide everything by 3, is 4x minus 7 over 3. So in other words, from all of this, this is saying when x equals 1/3, dy by dx has to equal 4. That is your slope. Okay, so let's crack on to that. So again, when in doubt, differentiate. Let's differentiate dy by dx equals 6x plus a, and now I can use this bit of information here. So I'm going to substitute x is 1/3, so 6 times 1/3 is 2 plus a, and that has to equal 4, right? Because it said the derivative is 4. So therefore, we've got a is 2. Huzzah! How are we meant to get b? This is when you need to realize what is going on. So 3x squared plus ax plus b. So we know that this is a quadratic. Now, not really worried about where exactly it sits on our axis. Let's imagine it's there. Sorry, I wanted to change color. Why is it not being there? We go. So let's imagine it's there. And we have the equation of a tangent. X equals 1/3, the slope is 4, so it's going to be positive. So let's just imagine, obviously, 1/3, that's a crazy scale. Can you see that at this point, that point there when x is 1/3, that point not only lies on the quadratic, it also lies on my tangent, okay? So using the equation of my tangent here, I can find out what my x value is. So at the moment, sorry, I know my x value. I'm going to use that to find out my y value. So I'm going to substitute 1/3 minus 7/3. So we get 4 times 1/3 is 4/3 take 7/3. All right, 4/3 take 7/3 is minus 3 over 3, which will be minus 1. So remember, what did we want to do to find a and b? We now know that 1/3 minus 1, not only does that lie on my tangent, but this point also lies on my original quadratic. Okay, so I'm going to sub that in to my quad. Okay, so we now know that, we'll do it over here. What do we know? Okay, so from our original, instead of 3x squared plus ax plus b, we now have discovered that a was 2, so I've substituted it in. And now I'm going to substitute in my point that lies on this line, minus 1/3 minus 1. So y value is minus 1. 3 times 1/3 squared. 1/3 squared is 1/9 times 3 is 1/3. plus 2/3 plus b. So what do we got there? 1/3 plus 2/3 is 1. So b therefore is -2. Okay, suss that. Just want to wrap it up, otherwise it becomes a very long video. Hopefully that's given you a little bit of a heads up with these questions, and it will help you finish exercise 15B.